you all that you're able to ask your questions in the chat box in order to get answered in the end. And let me introduce now our third speaker, Dr. Filippos Papadopoulos, the Director of the Strategic Project Management Office from the American Farm School, SKG, and responsible for the Agri-Food Entrepreneurship Centers run by the American Farm School. Dr. Papadopoulos is going to talk about the prospects and obstacles for the adoption of digital technologies in Greek agriculture. Dr. Papadopoulos, the floor is yours.
Thank you. Today I'm going to share with you our experiences and our thoughts on the prospects and obstacles for the adoption of digital technologies in Greek agriculture from the point of view of the American Farm School. Now I would open my presentation by saying quite strongly that at least in agriculture there are feelings of both strong attraction and ambivalence towards digital architecture. One can say that from the statements of the Berlin Agriculture Ministers Conference this year, that although digitalization is unavoidable and perhaps desirable for achieving the target of food for all, nevertheless, it carries a number of threats. One is a digital divide, especially between big and small farmers and rich and developing nations. Second, there is a dependency or a threat of a dependency on tech providers on the part of farmers. There is the huge issue of data ownership and data privatization. And finally, the issue of technological sovereignty. Of course, the EU has chosen to take advantage of the opportunities offered by digital agriculture, and this is reflected in the Green Deal. And the question then is, how is Greece going to perform in this situation? Now, as a non-expert, I understand digital farming through an anthropomorphic paradigm. In terms of sensors, we have sensors, both proximal and distal, and at least in Greece, there is some progress along these lines. In terms of neural systems, telecommunications, and so on, we have a long way to go, both in terms of development and in terms of prices. In terms of artificial intelligence, decision support systems, and so on, for agriculture, we are in early beginnings. And in terms of automations, we are not really there at this stage. The most promising field is that of irrigation. Turning to the enablers of this process towards digitalization, I would say that the main enabler is the pressure from consumers and citizens for demand, because of their demand for food that is friendly to their environment, is demonstrably healthy, it has a clear provenance, and the system gives them many choices at competitive prices. And these pressures are transmitted via the supply chains, political legislations, technology and service providers, though you could say that the last group is push rather than pull. Now, it's important to identify the supply chains as very important pressure channels because it is the dominant role of the retailer that allows this group of businesses to more or less impose its wills on the links further down the chain. Turning to the prerequisites on the part of the farmers for the adoption of digital technologies, from experience, we have identified the following factors. First of all, is high added value per strema, per land, of the produce that will be served. People who are engaged in, let's say, fruits or table olives and so on, they can afford the new technologies. Second is the twin question of, on the one hand, training, and on the other hand, self-confidence of the farmers. Perhaps more important is the question of motivation of the agronomists, that they are the field consultants for these farmers, because they have to adopt a new business model more than anything else. And of course, it's the huge question of the practical usefulness of these technologies to the farmers themselves. This increase is significant in the sense that we tend to have smaller plots than average, so to make visible the financial returns of these technologies, it's a bit more difficult. I have two graphs here. They are from sensors that we employ. You can see on the top a weather forecast graph, pretty straightforward for a farmer to read. And at the bottom, you can see soil moisture. Now, that needs interpretation in order to be useful to the farmer. And of course, here is the role of the agronomist. If the agronomist is not willing to collaborate, the farmer will not make much sense of this. To expand a bit on this example of moisture data, in order to make sense of it, the farmer needs to combine this information with soil analysis and with knowledge about the water needs of the cultivation over its life cycle. In this specific example that I give you here, it's a real life example. You can see that the farmer is over-irrigating, which means that he's wasting resources, reducing the quality and the yield of his crop, and increasing the soil-borne diseases. In other words, he has to spend more money on agrochemicals. So you could say that the business case is there. It's obvious. However, if we ask ourselves, can he figure all this out on his own? The answer is no. He needs an agronomist. Can anybody guarantee the data quality as a basis for decision making for this farmer? Again, at this stage, the answer is no. Will the agronomist who is supposed to be consulting him will be happy to sell him fewer fungicides? Again, the answer is no. Does this farmer pay for the water at this stage? Not yet. So if we ask the final question, is he likely to change his behavior and irrigate less? As things stand, probably not. These kind of issues have led us to the conclusion that what we need is social innovation in order to come to the rescue of technological innovation. And we try to do that by building communities of practice, by creating a three-tier system whereby we have peer learning between farmer groups across different regions on similar cultivations. We have peer learning among agronomists that serve them as consultants. And of course, we have our own experts that visit all the places and try to keep this process active. And in order to connect the dots between all these different locations, we utilize a LoRa telecommunications, IoT telecommunication network, which is a prerequisite really for a reasonably priced expansion and underlines our ability for e-consultancy. Currently, we have about 65 gateways with a technical capacity of over 60,000 sensors. Moving a step further away from the social innovation and towards a business model innovation, AFS has recently established and is now coordinating a vertically integrated cluster from farmers to retailers called Internet of Food Alliance. It is on a national level, and through it, we try to introduce a new business model of collaboration, not in order to replace, because that would be unrealistic, but in order to enhance the existing model of competition between the different links of the supply chain, the classical Porter model, let's say. Now, as I said at the beginning, digital technologies are a tool. They are not an end in themselves. So the question is, what direction do you give to the implementation of these AgTech? Cost reduction as a promise on its own is not enough for the farmer. We need to develop a value creation proposition to make these products that are produced through these technologies more attractive in the market. Also, we have to adopt a transdisciplinary food systems approach, which has to be extended all the way into university syllabi. From experience, we find that young agronomist graduates and food science graduates are not really aware of the digital technologies. So the next generation is not there as things stand. We need to combine knowledge transfer, which means research organizations talking with farmers, with experience transfer. Farmers, peer learning among farmers. And this has to be both interregional and intergenerational. And finally, engage retailers, as I've so often said, in order to make that innovation visible to the consumers. In the pictures that I have here to the right, you can see a middle-aged farmer trying to show what manure looks and feels and smells like to a young student. And you can see the young agronomist's reluctance to engage. In the picture in the bottom, you can see efforts to utilize biostimulants in collaboration with digital technologies for soil enhancement. Thank you for your attention. I'm available for any questions you might have. Thank you.
Well, thank you, Dr. Papadopoulos, for your presentation and your input. Of course, the chat is open for your questions in order to get answered in the end by our speakers. And now we move on to our last